Imagine your company's network, right? Like as a physical office building.
Okay.
For decades, the security strategy was just, well, simple. You build a massive brick wall around the perimeter, you put a heavy lock on the front door, and, you hire a security guard to check badges.
Right, the classic castle and moat.
Exactly. And once you were inside that building, you were trusted.
Yeah.
I mean, you could walk into any conference room, you could open any filing cabinet, talk to anyone.
Because the assumption was, if you're inside, you belong inside.
Right. But now, imagine taking that exact same company, tearing down all the physical walls, scattering the desks across, 50 different countries, and just leaving the front doors wide open to the public internet.
Which is terrifying when you put it like that.
It is terrifying, right? Yet, this is exactly the environment modern businesses operate in every single day.
It's a massive paradigm shift. I mean, the perimeter is completely gone. And when you no longer have a physical building to protect, you have to completely, rethink what security and infrastructure even mean.
Yeah, it's a whole new world.
You're no longer defending a place, You are defending the data itself and the identity of the person trying to access it.
Welcome to the deep dive. Today, we are decoding the invisible infrastructure that makes all this modern distributed work possible. We are plunging into the Microsoft 365 ecosystem.
Yes, we are.
And to be clear, right up front, for you listening, if you hear Microsoft 365 and you just think of typing a document in Word or making a quick spreadsheet in Excel, you are missing 90% of the picture.
Oh, at least 90%. That is such a common misconception.
Right.
We're going to look under the hood at how these tools actually function at an enterprise level. So we'll break down the core cloud computing models, IaaS, PaaS, and SaaS, and explain how they physically operate.
Giving you the concrete examples.
Exactly. We'll explore the back-end architecture of the apps that hybrid workers actually rely on, and then we're going to spend a significant amount of time on the active defense mechanisms.
Which is the fun stuff.
Oh, the best stuff. The zero trust principles, the threat detection algorithms, the data governance policies, basically everything that keeps a company from ending up on the front page of the news after a massive cyber attack.
And there is a very specific reason we are taking this approach today. If you're preparing for the MS-900 exam, that's the Microsoft 365 Fundamentals certification, this deep dive is literally your conceptual roadmap.
Absolutely. The apps and services make up, 45 to 50% of that exam?
Yeah, it's a huge chunk.
And the security and compliance side is growing heavier too, probably sitting around 25 to 30% now. So we are focusing exactly where the points are.
Exactly. But hey, even if you have zero interest in taking an IT exam tomorrow, understanding this architecture is essential. I mean, this is the environment you work in.
It affects everything you do.
Yeah, this is how your company tracks your devices, secures your emails, and, prevents data leaks. So let's start at the absolute bedrock. Before we can talk about the applications themselves, we really have to understand the environment they live in, the cloud.
Right. And the cloud is such a nebulous term, which is, I guess, ironic given the name.
Very ironic.
But stripped of all the marketing jargon, the cloud is essentially a massive, highly optimized network of data centers. Like we said earlier, it's someone else's computer.
Yeah.
But the fundamental business shift, and this is key for the exam, isn't just about where the computers are located. It's about how you pay for them and how you manage them. We are talking about the shift from capital expenditure to operational expenditure.
Okay, break that down for me. Because historically, if a company wanted to, say, launch a new internal application, the IT department had to go to the finance department.
Hat in hand.
Right, hat in hand, and ask for a massive budget to just buy physical metal servers.
Yeah, and that is capital expenditure, or CapEx. You're making a huge upfront investment in physical assets.
The actual hardware.
Right. You buy the servers, you buy the racks, you pay to upgrade the cooling system in your server room, and you have to hire technicians to just maintain all that hardware.
Sounds expensive.
It's incredibly expensive. But the real danger with CapEx is that you have to guess your future capacity.
Oh, like predicting the future.
Exactly. If you buy 10 servers and your new application is a massive failure, well, you're stuck with 10 expensive depreciating pieces of metal just gathering dust.
Ouch.
Conversely, if your app is wildly successful and you suddenly need 20 servers, your system just crashes until you can order, ship, and install new hardware.
So it's just incredibly rigid. You are completely locked into whatever hardware you purchased. Which brings us to operational expenditure, right? OpEx.
Yes. OpEx treats computing power like electricity. It becomes a utility.
Okay, I like that analogy.
Think about it. When you flip a light switch in your house, you don't care how the power plant generated the electricity, right?
Yeah, no, I just want the light to turn on.
Right. You just consume it and pay for exactly what you used at the end of the month. That is the public cloud model in a nutshell. Providers like Microsoft Azure or Amazon Web Services, they build these hyperscale data centers.
Massive ones.
Huge. And you just rent compute power, storage, and network bandwidth on a pay-as-you-go basis. If your application goes viral, the cloud provider instantly, dynamically allocates more resources to you. Automatically.
Yeah.
And if traffic drops, you scale down and your bill drops immediately.
Okay, I get that. But I want to push back a little on the idea that the public cloud is the perfect solution for absolutely everything.
Okay, fair enough.
Because, like, if I'm a highly regulated financial institution or a healthcare provider dealing with, really sensitive patient records, I might not be legally allowed to put my data on a shared infrastructure, even if Microsoft security is amazing.
That is a very real constraint, and honestly, it's the exact reason the private cloud exists.
Okay, so what makes it private?
A private cloud uses the same virtualized, scalable technologies as a public cloud, but the underlying hardware is dedicated exclusively to one single organization.
So I'm not sharing a server rack with, like, a random startup.
Exactly. You're not sharing with anyone. It can be hosted in your own physical data center, or you can actually pay a third-party provider to host a private environment just for you.
Oh, I see.
Yeah, so you get the agility of cloud software, but you maintain absolute physical control over the hardware and the data sovereignty.
But the downside there is I'm assuming you are back to buying the hardware. You take on that CapEx burden all over again, and you have to employ the engineers to fix the physical servers when a hard drive inevitably fails.
That's the trade-off, which is why the vast majority of modern enterprises don't choose strictly one or the other. They use a hybrid cloud.
Best of both worlds.
Exactly. This is an integrated architecture that connects an organization's on-premises private cloud with a public cloud provider.
Give me a tangible example of how a company actually utilizes a hybrid cloud in the real world. Like, why split your resources like that?
Sure. Consider a major retail chain during the holiday season. Throughout the year, they run their core inventory databases and their employee payroll systems on their highly secure private cloud infrastructure.
Right, keep the sensitive stuff locked down.
Exactly. The traffic is predictable, so it works perfectly. But on Black Friday, the traffic to their consumer-facing e-commerce website might spike by, 1,000%.
Yeah, the site gets hammered.
And their private cloud just cannot handle that load.
So instead of buying millions of dollars in permanent servers just for that one weekend of crazy traffic, they use the public cloud for the overflow.
We call that cloud bursting.
Cloud bursting, I like that.
It's very descriptive. The application architecture is designed so that when the private cloud hits, say, 90% capacity, it automatically seamlessly routes the excess user traffic to temporary scalable servers in the public cloud.
That's smart.
And once the holiday rush is over, those public servers are spun down and the company stops paying for them. It is the ultimate combination of security and cost efficiency.
Okay, so that establishes the where of the infrastructure, public, private, or hybrid. But we also need to look at how a company actually consumes that infrastructure, the service models.
Ah, yes. The classic IT alphabet soup.
Exactly. IaaS, PaaS, and SaaS.
Right. And really, these models simply define the dividing line of responsibility between the cloud provider and the customer.
Like a sliding scale.
Exactly like a sliding scale of management. Let's start at the foundational layer. Infrastructure as a service, or IaaS. In this model, the cloud provider is only responsible for the physical hardware, the physical security of the building, and the raw network connection.
So they just give you the machine.
They hand you a virtual machine, and that is it.
So if I rent an IaaS server from Microsoft Azure, I am getting a completely blank slate. Like, there's no operating system on it. It's just raw compute power.
Correct. You, the customer, are responsible for installing Windows or Linux. You are responsible for configuring the firewall rules.
Wow. Okay.
And crucially, if a new critical security patch comes out for the operating system, you have to log in and install it. If you don't and the server gets hacked, that is entirely your fault, not Microsoft's.
Why would a company want that headache? I mean, if the whole point of the cloud is to outsource the heavy lifting, why stop at the bare metal?
Control and legacy compatibility.
Oh, old software.
Yeah, many organizations have older, custom-built applications that require very specific, perhaps outdated, operating system configurations to even run. They can't just throw those apps onto a modern platform.
A break.
Exactly. So IaaS app gives them the precise, granular control they need to replicate their old physical server environment perfectly in the cloud.
Okay, that makes sense. Moving one step up the stack, we have Platform as a Service, or PaaS. How does the responsibility shift here?
With PaaS, the cloud provider takes on significantly more of the burden. They manage the physical hardware, sure, but they also manage the operating system, the network configuration, the middleware, and the database management systems.
So they are providing a complete, ready-to-use framework.
Exactly.
Okay, but if the provider is managing the operating system and the databases, what is actually left for the customer to do?
The code.
Just the code.
Just the code. PaaS is designed almost exclusively for software developers. Imagine a team of engineers building a new mobile app for their company. They don't want to waste time figuring out how to balance load traffic across servers or managing database backups or, patching the underlying Windows server.
They just want to write the app.
Exactly. They just want to write the Python or C# code and deploy it. PaaS gives them an environment where they upload their code, and the platform automatically handles all the back-end infrastructure required to make that code run globally.
It abstracts away the plumbing so the developers can focus on building the house.
That's a really solid way to visualize it. And that leads us to the very top of the stack, which is what 99% of everyday employees interact with: software as a service, or SaaS.
The ultimate utility model.
Yes. In a SaaS model, the cloud provider manages absolutely everything: the hardware, the operating system, the middleware, the application code, the data storage, the security patching.
Everything.
Everything. You, the customer, simply open a web browser, log in, and consume the application.
Which brings us perfectly back to our main focus today. Because Microsoft 365 is arguably the most complex, comprehensive SaaS application on the planet.
Oh, without a doubt.
But before we get into the features of that SaaS model, we need to address a naming convention that causes just endless confusion. I hear people use Office 365 and Microsoft 365 interchangeably all the time. Are they the same thing?
They are absolutely not the same thing, and understanding that distinction is a foundational concept, especially if you are evaluating licensing for your company or sitting for the MS-900 exam.
Okay, clear it up for us.
Office 365 is the suite of productivity applications. It is Word, Excel, PowerPoint, Exchange for your email, and Microsoft Teams. It's the stack where you use to create and communicate.
I call it the digital desk.
The digital desk, exactly.
Yeah.
Microsoft 365, on the other hand, is a much larger umbrella. It includes the entire Office 365 suite, yes, but it adds two massive critical components on top of that.
Which are?
First, it includes the Windows operating system itself, specifically enterprise versions like Windows 10 or 11. Second, and most importantly, it includes Enterprise Mobility and Security, which is known as EMS.
Okay, so let me make sure I have this. Office 365 is just the software you are typing your report into. Microsoft 365 is that document software, plus the operating system running on the physical laptop, plus the security tools enforcing corporate policy on that device. It's the whole ecosystem.
That is the crucial difference. Microsoft realized that in a world of remote work, providing cloud-based Word documents just wasn't enough if the laptop accessing those documents was compromised. They needed to bundle productivity with endpoint management and security.
That makes total sense. So let's dig into that productivity side first, specifically how these everyday SaaS tools actually function together on the back end to help hybrid workers.
The big three.
Right, the core trinity. Microsoft Teams, SharePoint Online, and OneDrive. Most people think of Teams as just a chat app, or a Zoom alternative, but architecturally it's something entirely different, isn't it?
It really is. Microsoft Teams is best understood as a graphical user interface, a wrapper, that aggregates other Microsoft 365 services into one single pane of glass.
Wow, wrapper.
Yeah, it is a unified collaboration hub. When you are looking at a Teams channel, you are actually looking at a composite of several different underlying technologies.
Walk me through what happens under the hood then. Let's say a user creates a new team for a specific project, and then they upload a PDF document into that Teams file tab. Where does that file actually go? Because it doesn't live, inside the chat window.
This is a vital mechanism to understand, and they test this heavily. The moment a user clicks Create Team, the system silently provisions several resources in the background. Most importantly, it creates a dedicated SharePoint Online site.
Oh, I didn't realize it did that automatically.
Yep. It's seamless.
Yeah.
So when a user uploads that PDF into the Teams interface, Teams uses an API to push that file directly into the document library of that associated SharePoint site.
So SharePoint is the actual storage engine. Teams is just the display window.
Exactly. SharePoint Online is the corporate content management system. It provides the robust version control, the document co-authoring capabilities, the granular permission structures. Teams simply surfaces that SharePoint data in a way that is easy for humans to interact with, right alongside their daily chat and video calls.
Okay, so if SharePoint is storing the Teams files, how does OneDrive fit into this architecture? What is the purpose of OneDrive?
If SharePoint is the departmental filing cabinet, OneDrive is the employee's personal encrypted briefcase.
I like that.
And architecturally, OneDrive for Business actually runs on the SharePoint engine.
Wait, really?
Yeah, it is essentially a specialized, isolated SharePoint site provisioned for a single user. It is where you store your draft documents, your personal notes, or files you are not quite ready to share with the broader team yet.
And the major advantage here goes right back to the SaaS model we talked about, because that briefcase lives in the Microsoft data center, not on the local hard drive. So if a remote worker spills coffee on their laptop and completely destroys the motherboard, their data isn't lost. They just receive a new laptop, authenticate into Microsoft 365, and their OneDrive immediately syncs all their personal files back to the new device.
That resilience is key for hybrid work. But you've just highlighted the next major logistical problem for an IT department.
The coffee spill.
Well, the devices themselves. Remote workers are constantly breaking, losing, or replacing laptops. If the company network has no walls, how does the IT team actually manage, update, and secure the physical endpoints, the laptops and mobile phones sitting in employees' living rooms?
Right, because in the old CapEx days, an IT tech would literally physically walk to your desk, plug in a USB drive, and install the new software. Obviously, that doesn't scale globally.
Historically, enterprises used an on-premises solution called Microsoft Endpoint Configuration Manager. It was a massive server that pushed updates to PCs, but the crucial limitation was that the PC had to be physically connected to the corporate network.
Either plugged into a wall in the office or on a really slow VPN.
Exactly. To solve this for the cloud era, Microsoft introduced Intune.
So Intune is the SaaS approach to device management.
Intune is a 100% cloud-based mobile device management and mobile application management solution, MDM and MM. It doesn't care if the user is on the corporate network or sitting in a coffee shop on public Wi-Fi.
As long as there's internet.
As long as the device has an internet connection, Intune can reach it. An administrator in New York can use the Intune portal to silently push a critical security patch to a laptop in Tokyo.
Wow.
They can enforce a policy that requires a 6-digit PAN on a corporate iPhone, or remotely wipe all company data off a tablet that an employee left in a taxi.
That's powerful. But wait, a lot of massive corporations still rely heavily on their old configuration manager servers. I mean, they have a decade of custom scripts and application deployments tied up in that on-premises system. They can't just delete it overnight and move everything to Intune.
Which is why Microsoft built a bridge called co-management.
Yeah.
Co-management allows a Windows device to be managed concurrently by both the legacy on-premises configuration manager and the cloud-based Intune service.
How does a laptop know who to listen to if it's receiving commands from two different management systems? Doesn't it get confused?
The IT administrator sets specific workloads in the console. For example, they might configure the system so that Configuration Manager still handles the deployment of massive, complex desktop applications.
The heavy lifting.
Right. But they slide a toggle that hands over the responsibility for Windows updates and compliance policies to Intune in the cloud. It allows an enterprise to transition to the cloud at their own pace, workload by workload.
I see where you're going with this, but let's push this concept to its logical extreme. If the data is in SharePoint and the management is handled by Intune over the internet, why do we even need to give employees expensive corporate laptops?
That's a very good question.
Right. Why not just stream the computer itself from the cloud? The sources talk about desktop virtualization, specifically Windows 365 and Azure Virtual Desktop.
Desktop virtualization is becoming incredibly popular because of data security and logistics. Instead of shipping a $2,000 laptop to a new remote hire, you just tell them to use their own personal home computer or a cheap tablet, and they log into a virtual Windows machine that lives entirely in the Microsoft data center.
The MS-900 exam clearly distinguishes between Windows 365 and Azure Virtual Desktop, or AVD. But conceptually, they sound identical. They both put Windows in the cloud. What is the actual architectural difference?
It comes down to complexity, resource sharing, and billing. Let's look at Windows 365 first. Windows 365 is a pure SaaS solution. It's designed to be as simple as possible. It provisions a cloud PC that is dedicated to one single user.
Okay.
It is highly personalized. You get a fixed amount of RAM, a fixed amount of storage, and you pay a flat, predictable monthly fee. Essentially a Netflix subscription for a computer.
So if I'm a small business owner and I want to give my accountant a secure environment to process payroll, I buy one Windows 365 license. The accountant logs in, uses their dedicated cloud PC, and I know exactly what my bill is going to be every single month.
Precisely. Now contrast that with Azure Virtual Desktop.
Huh?
AVD is a highly complex mix of PaaS and IaaS. It's an enterprise-grade platform designed for IT architects. The fundamental technical difference is that AVD supports multi-session Windows environments.
Meaning multiple human beings are actively using the exact same virtual machine at the exact same time.
Yes. You might provision one incredibly powerful virtual server in Azure and have 20 call center employees logging into it simultaneously, each seeing their own isolated desktop.
Wow, okay.
Because you are pooling resources, it can be much more cost-effective at scale. Furthermore, AVD uses consumption-based pricing. You don't pay a flat monthly fee. You pay for the exact compute resources, the CPU cycles, and the network bandwidth that those virtual machines actually consume.
So if my call center workers all log off at 5:00 p.m. on Friday, and I configure my AVD environment to automatically power down those virtual servers over the weekend, my billing meter literally stops running.
That is the beauty of consumption-based OpEx. But managing the auto-scaling scripts, configuring the host pools, monitoring the network latency that requires significant technical expertise, Windows 365 sacrifices that granular control in exchange for absolute simplicity.
Okay, that makes perfect sense. But whether you are using a physical laptop managed by Intune or a virtual machine in Azure, those operating systems are constantly evolving. I remember the nightmare of traditional IT upgrades.
Oh, don't remind me.
You used Windows 7 for 5 years, and then the IT department forced everyone to upgrade to Windows 10, and for a week, half the legacy software in the company just stopped working. The modern approach is Windows as a service, right?
Yes, Windows as a Service abandons those massive, monolithic Big Bang upgrades. Instead, Microsoft delivers continuous, incremental feature updates and security patches. It treats the operating system like a living organism that is constantly evolving.
But if an operating system is constantly updating, doesn't that increase the risk of an update breaking a critical corporate application? Like, if Microsoft pushes a bad update on a Tuesday night, the entire global workforce could wake up to blue screens on Wednesday morning.
That is a critical risk, and the mitigation strategy is a core concept tested on the exam. Deployment rings. An organization never deploys a feature update to all devices simultaneously. They use Intune to segment their endpoints into strategic rollout rings.
Walk me through the mechanics of a deployment ring.
Let's say a new Windows feature update is released. First, it hits the test ring, which might just be 5 laptops belonging to the IT engineering team. They evaluate it for a week.
Guinea pigs.
Exactly.
Yeah.
If those machines remain stable, the update automatically expands to the pilot ring or limited ring. This might be 5% of the workforce, perhaps specific power users across different departments. They use it for 2 weeks. Only after the telemetry shows 0 compatibility issues or system crashes does the update finally move to the broad ring, which covers the remaining 95% of the company.
It's a localized blast radius. If an update breaks the finance department's proprietary spreadsheet software, it only affects the 2 finance users in the pilot ring, and IT can pause the rollout before it destroys the productivity of the entire company.
It is risk management systematically applied to software updates.
All right, let's step back and look at what we've built so far. We've established the cloud infrastructure. We have users collaborating in Teams and SharePoint. We have their laptops managed over the internet via Intune. We are a fully modern, distributed, hybrid organization.
A beautiful setup.
It is, but we are now facing the most critical vulnerability of this entire architecture. If there is no corporate network perimeter, if there is no firewall protecting the building, how do we stop malicious actors from walking right through our digital front door?
You're touching on the core issue, which is the complete obsolescence of traditional perimeter security. The industry standard response to this, and a framework you absolutely must understand inside and out for the exam, is the zero trust model. Zero Trust is not a specific product you can buy. It is a fundamental architectural philosophy.
I want to break this down without relying on the cliche castle and moat analogy everyone always uses. I think a better way to visualize zero trust is to imagine a high-end, modern casino floor.
I like that. Let's explore the mechanics of that.
So in a traditional perimeter model, the security is all at the front door, right? The bouncer checks your ID, and once you are inside the casino, you're trusted. You can walk up to the high roller table, you can wander toward the vault, you basically have free reign.
Right.
But a real modern casino doesn't work like that at all. They assume that someone who walked through the front door might be a card counter or a pickpocket. So the security is completely decentralized. Every single gaming table has cameras monitoring behavior. The chips have RFID tags tracking their movement. Pit bosses are constantly evaluating the context of every single bet. Even though you are inside, you are continuously scrutinized.
That's a phenomenal analogy for the three guiding principles of Zero Trust. Let's align them. Principle number one is verify explicitly. In the old model, if an employee logged in from a trusted corporate IP address inside the building, the system implicitly trusted them.
They pass the bouncer.
Right. But Zero Trust says that network location is completely irrelevant. You must explicitly authenticate and authorize every single access request based on all available data points.
What kind of data points are we looking at?
We look at the user's identity, their location, their device's health status, the specific app they're trying to access, and any behavioral anomalies. Is the laptop's antivirus turned on? Is the operating system fully updated? If the device is unpatched, it doesn't matter if you have the correct password, you are not getting in.
Wow. Okay, principle number two is least privilege access.
Continuing your casino analogy, a bartender has access to the liquor room, but they don't have access to the cash vault. Least privilege means granting a user only the minimum level of access required to perform their specific job and absolutely nothing more. And importantly, it shouldn't be permanent access.
Right. The sources mention just-in-time and just-enough access, JIT and JEA. Explain the mechanics of a just-in-time token.
Let's say a senior engineer needs to troubleshoot a critical database server. Traditionally, IT would just make them a permanent global administrator.
Which is terrifying.
It is. Because that means if that engineer's account is ever hacked, the hacker has permanent global admin rights. With just-in-time access, the engineer just has standard user privileges day to day. When they need to fix the server, they submit a request. The system grants them elevated privileges, but issues a token that mathematically expires in exactly 2 hours.
Oh, I see.
Once the 2 hours are up, their access is automatically revoked. The window of vulnerability is drastically minimized.
And the third principle of zero trust is assume breach. Now, this sounds like an incredibly pessimistic way to run an IT department.
It's not pessimistic, it's realistic. If you operate under the assumption that sophisticated attackers have already bypassed your perimeter and are currently inside your network, it forces you to design entirely different internal defenses.
Like what?
You implement end-to-end encryption. You use microsegmentation, meaning you divide your network into tiny, isolated zones so that if a hacker compromises an HR server, they can't laterally move to the engineering servers. You deploy analytics to constantly hunt for anomalous behavior.
Okay, so if we are verifying explicitly at every single interaction, there has to be a central authority making these decisions. Who is the pit boss evaluating all these signals in real time?
In the Microsoft 365 ecosystem, that central authority is Microsoft Entra ID. You may see older documentation refer to this as Azure Active Directory, but the new branding is Entra ID. It is the cloud-based identity and access management service. It is the ultimate gatekeeper.
Identity is complex, though, because an enterprise doesn't usually start from scratch. They usually have a server room in their basement running traditional local Active Directory that they've used for 20 years to manage employee logins. How does that old physical server interact with Entra ID in the cloud?
And that requires understanding the three types of identity models. First, you have cloud-only identity. This is simple. The user accounts are created directly in Entra ID, and they only exist in the cloud. This is common for brand new startups that have no physical servers.
Second would be on-premises identity, where everything lives on the local server.
Correct, but that doesn't allow access to cloud SaaS apps. So 99% of enterprises use the third model, hybrid identity. They use a tool called Microsoft Entra Connect. It's a synchronization engine. It takes the user accounts from the legacy, on-premises Active Directory server, and securely synchronizes them up to Entra ID in the cloud.
Why go through that trouble? Why not just make the user remember one password for the local network and a different password for their cloud email?
Because password fatigue is a massive security risk.
Hmm.
If you make an employee remember 15 different complex passwords, they're going to write them down on a sticky note and put it right on their monitor. Hybrid identity enables single sign-on or SSO.
Explain the mechanism of an SSO token exchange, because it's not just the system typing the password in for you behind the scenes, right?
Exactly. When a user arrives at work, they log into their laptop using their hybrid identity credentials.
Mm.
Entra ID verifies the password and device, and then issues a cryptographic token, often a SAML or OAuth token.
Oh.
When that user subsequently opens their web browser and tries to access Salesforce or Workday or SharePoint, they don't type a password. The application talks to Entra ID. Entra ID passes the secure token to the app saying, hey, I've already verified this user, and the app grants access. The user only authenticates once.
The convenience is undeniable, but the security flaw seems glaring to me. If an attacker manages to steal my one password or phish my credentials, they now hold the master key to every single application in the company via SSO.
Which is precisely why Entra ID mandates the use of multi-factor authentication, or MFA. Passwords alone are effectively useless against modern automated attacks. MFA requires the user to present a combination of at least 2 different forms of authentication from 3 possible categories.
Let's clearly define those categories for the exam. Something you know, something you have, and something you are.
Right. Something you know is the knowledge factor, typically the password or a PIN. Something you have is a physical possession factor, like a trusted smartphone running the Microsoft Authenticator app, a hardware security key, or a smart card. And something you are is an inherence factor, a biometric characteristic like a fingerprint scan, facial recognition via Windows, Hello, or an iris scan.
Let's talk about the something you have factor, specifically text messages. For years, every bank and website sent you a 6-digit SMS code to log in. But the security industry is moving aggressively away from SMS. Why?
Because text messages are terrifyingly vulnerable to a technique called SIM swapping.
Oh, I've heard of this.
Yeah, an attacker can call your mobile carrier, impersonate you, claim they lost their phone, and convince the customer service rep to port your phone number to a new SIM card controlled by the attacker. Suddenly, they are receiving all your MFA text messages. This is why Microsoft strongly pushes for push notifications or time-based one-time passwords generated locally inside the Microsoft Authenticator app, rather than relying on insecure cellular networks.
I want to highlight a trap that often catches people off guard on these exams. You might see a system prompt that asks you, what was the make and model of your first car? Or, what is your mother's maiden name? These are custom security questions. Are those considered a valid form of MFA?
Absolutely not. Microsoft does not consider custom security questions a supported MFA method. The problem is social engineering. In the age of social media, it is trivial for an attacker to scroll through your Facebook feed, find a picture of your first car, and look up your mother's maiden name on an ancestry site. They're not secure authentication factors.
Good to know. So we have SSO, we have MFA with the Authenticator app. But requiring an employee to pull out their phone and approve a push notification every single time they open a new document is going to destroy productivity. How does Entra ID balance security with user friction?
It uses the intelligent brain of the zero trust model, conditional access. Conditional access is a sophisticated policy engine. It analyzes the signals of a login attempt in real time, evaluates the risk, and applies an if-then logic structure.
Walk me through a complex conditional access scenario. How does it actually calculate risk?
Let's say you log into your corporate email every weekday at 9:00 a.m. from your company-issued laptop in your home office in Chicago. Entra ID recognizes the device footprint, the IP address, and the geographic location.
It knows it's me.
Right. The conditional access policy evaluates those signals, determines the risk is low, and grants you access seamlessly via SSO without prompting for MFA. You don't even notice it happened.
But then 3 hours later, a login attempt occurs.
Right. At 12:00 p.m., a login attempt using your exact username and password originates from an anonymous VPN IP address known to be associated with a server farm in Eastern Europe.
The impossible travel scenario.
Yes, the physics dictate that you cannot travel from Chicago to Eastern Europe in 3 hours. Conditional access immediately flags this as high risk. The if condition has been met. If the login risk is high, the policy then executes the then control.
So it blocks them.
Well, the policy doesn't just blindly grant access because the password was correct. It might immediately demand an MFA prompt. The attacker in Eastern Europe has your password, but they don't have your physical phone to approve the push notification, so the attack fails. Or, if the policy is strict enough, it might just proactively block the authentication entirely and alert the IT security team.
Conditional access applies friction only when the context demands it. That is brilliant architecture.
That
But playing devil's advocate here, what happens when conditional access fails?
It happens.
Right. What if the attacker didn't steal a password from across the globe, but instead they compromised the physical laptop of the employee sitting in Chicago through a highly sophisticated spear phishing email? The attacker is now operating from a trusted device on a trusted IP with a trusted identity. They have bypassed the pit boss entirely.
This is where we shift from identity and access management into the realm of active threat protection. We move into the Microsoft Defender ecosystem. This makes up a massive portion of the MS-900 exam objectives. The industry term for this suite is XDR, Extended Detection and Response.
Explain the extended part. Why not just call it antivirus?
Because traditional antivirus is completely siloed. Your endpoint antivirus might see a suspicious file, and your email security gateway might see a suspicious email, but they don't talk to each other. Extended means the system correlates telemetry across multiple domains, endpoints, email, identities, and cloud apps into a single, unified investigation. It connects the dots.
Let's break down the major pillars of the Defender XDR family, starting with the endpoints themselves. Microsoft Defender for Endpoint.
Defender for Endpoint is a comprehensive endpoint security solution. It goes far beyond scanning for known malware signatures. It uses behavioral sensors built deep into the Windows operating system core to detect advanced fileless attacks or ransomware execution patterns. And its most powerful feature is ARA automated investigation and remediation.
How does an automated remediation sequence actually unfold during a real ransomware attack?
Imagine an employee inadvertently executes a ransomware payload. The malicious script immediately begins attempting to encrypt the local hard drives. The behavioral sensors in Defender for Endpoint detect the rapid file modification anomaly within milliseconds. Milliseconds. The system doesn't just generate a passive alert for a human analyst to read later. AIR actively intervenes. It can automatically suspend the malicious process, delete the payload, and critically, it can issue a command to the Windows firewall to isolate the machine from the corporate network.
So it cuts off the laptop's ability to communicate with the internal network, preventing the ransomware from spreading to the main file servers, while still maintaining a secure administrative connection back to the Defender portal so IT can investigate.
Exactly. It operates at machine speed, stopping the lateral spread before a human even realizes an attack occurred.
But the best defense is preventing that malicious payload from ever reaching the endpoint in the first place. Which brings us to the second pillar, Microsoft Defender for Office 365.
This focuses entirely on collaboration threats, specifically email and Microsoft Teams. It protects against phishing, business email compromise, and malicious attachments. Two key mechanisms here are safe links and safe attachments.
How does safe links work? Because attackers are smart. They will send an email with a link that points to a legitimate, safe website. But 2 hours later, after the email has bypassed the security gateway and is sitting in the user's inbox, the attacker redirects that link to a malicious credential harvesting page.
That phenomenon is called weaponization post-delivery, and it's exactly what SafeLink solves. When an email arrives, Defender for Office 365 wraps the URL in a secure proxy wrapper. When the user clicks the link, even it's days later, the request is first routed through Microsoft security servers.
Oh, clever.
Yeah, the system detonates the link in a virtual sandbox, analyzes the destination page in real time for malicious code or phishing forms, and if it's safe, seamlessly forwards the user. If it has been weaponized, the user sees a massive red warning screen blocking access. Time of click verification is essential.
Okay, we've covered the endpoints and the emails. The third pillar is Microsoft Defender for Identity. Now, we already spent a lot of time on Entra ID. Why do we need a separate Defender product for identity?
Because Entra ID manages the cloud access, but Defender for Identity is a sensor that sits inside your local, on-premises Active Directory network. Its primary job is to detect compromised user credentials and, most importantly, lateral movement.
You've mentioned lateral movement twice now. Walk me through the anatomy of how an attacker actually moves laterally.
Well, let's say an attacker successfully phishes the credentials of a low-level employee, say a receptionist. The receptionist's account doesn't have access to the sensitive financial databases or the domain controllers. The attacker establishes a foothold on the receptionist's computer. They then begin silently probing the internal network, looking for vulnerabilities or exposed administrative credentials left behind in the memory of other servers. Their goal is to hop from server to server, escalating their privileges at each step until they compromise an enterprise admin account that effectively gives them the keys to the entire kingdom.
So the attacker is using valid, albeit stolen, internal credentials to move around. It doesn't look like a virus. It looks like a user doing normal network activity.
Which is incredibly hard to detect. Defender for Identity analyzes the normal behavioral patterns of every user. If the receptionist account, which normally only accesses the printer server and the intranet site, suddenly begins making highly sophisticated Kerberos ticket requests or attempting to enumerate the members of the domain admins group at 3:00 a.m., Defender for Identity flags that behavior as a lateral movement attack and alerts the Security Operations Center.
The final major pillar in the Defender family deals with a very modern problem, Microsoft Defender for Cloud Apps. The industry refers to this as a CASB, a Cloud Access Security Broker. What is the business problem a CASB solves?
The problem is shadow IT. In the SaaS era, anyone with a corporate credit card or even just a free email address can sign up for a cloud application. The marketing team might decide SharePoint is too clunky for sharing massive video files with an external agency, so they independently sign up for a Dropbox or a Google Drive account and start uploading gigabytes of unreleased, highly confidential corporate intellectual property.
And the IT department has absolutely no idea this is happening, which means they cannot enforce any data protection policies on that data.
Exactly. You cannot protect what you cannot see. Defender for Cloud Apps acts as a massive visibility engine. It ingests traffic logs from your corporate firewalls and secure web gateways to discover every single unsanctioned cloud application your employees are using.
So IT can run a report and say, wow, we have 400 employees using an unauthorized PDF conversion tool hosted in a foreign country.
Yes. The CASB assesses the security risk of that specific app, looking at its compliance certifications and terms of service. IT can then choose to officially sanction the app and bring it under Entra ID, single sign-on control, or they can issue a block policy that prevents any corporate device from connecting to that unsanctioned URL. It regains control over the decentralized SaaS landscape.
I'm putting myself in the shoes of an IT administrator right now, and frankly, my head is spinning. We have Defender for Endpoint analyzing hard drives, Office 365 detonating email links, identity hunting lateral movement, and cloud apps finding shadow IT. How on earth does a security team synthesize all this data without drowning in thousands of alerts every day?
That is the magic of the XDR integration. All of these separate products feed their telemetry into a unified dashboard, the Microsoft Defender portal. The algorithms automatically correlate isolated alerts into comprehensive incidents.
So it groups them together.
Exactly. Instead of seeing 50 scattered alerts, the analyst sees a visual timeline. User A clicked a phishing link in email detected by Office 365. They downloaded a payload to their laptop detected by endpoint. The payload attempted to extract credentials detected by identity and tried to upload a file to a suspicious cloud storage site detected by cloud apps. It tells the entire story.
And for the executives who don't understand the technical nuances of a Kerberos ticket attack, Microsoft provides a gamified metric to track overall posture, Microsoft Secure Score.
Secure Score is a brilliant governance tool. It continuously evaluates your entire Microsoft 365 environment against Microsoft's recommended security baselines. It gives you a numerical score percentage. If you were sitting at a 42%, it means you have massive configuration gaps.
But it doesn't just give you a bad grade and leave you to figure it out, right?
Yeah.
It provides a prioritized checklist.
Correct. It provides actionable recommendations with quantifiable impact. It will tell you, if you enforce MFA for all administrative roles, your score will increase by 9%. If you disable legacy authentication protocols, your score increases by 5%. Yeah. It gives IT leaders a roadmap to systematically harden their environment, and it provides a metric they can report to the board of directors to justify security investments.
All right, we have spent a lot of time talking about protecting the infrastructure from hackers and external threats. But there is another side to the security coin. What if the threat isn't a hacker trying to break in? What if the threat is an employee who already has legitimate access to the data, but they make a catastrophic mistake, or worse, they intentionally decide to steal it?
Now we are crossing the line from threat protection into data governance and compliance. This is the domain of Microsoft Purview. If Defender protects the perimeter and the devices, Purview protects the actual data payload, the intellectual property, the financial records, the customer privacy data.
Let's start with the malicious side, the insider threat. The sources highlight Purview Insider Risk Management.
Insider risk management is designed to identify deliberate or accidental risks originating from within the organization. It uses machine learning to correlate signals across Microsoft 365 to spot anomalous user activity.
What kind of signals are we talking about here?
Consider an employee who has just submitted their 2 weeks' notice. They are leaving to join a direct competitor. Suddenly, over a single weekend, they download 5,000 highly confidential CAD drawings from a restricted SharePoint site, attempt to compress them into a massive ZIP file, and connect an unauthorized external USB hard drive to their laptop.
The machine learning model sees that sequence of events, correlates it with the HR resignation signal, and flags it as a severe data theft risk. But how do you implement a system like that without creating a dystopian surveillance state that violates employee privacy and invites HR bias?
Privacy is a core design principle of insider risk management. When alerts are generated and surfaced to the security or compliance teams, the actual username of the employee is pseudonymized. It's replaced by a random string of characters.
Oh, that's smart.
Yeah, the investigators evaluate the severity of the action without knowing who took the action, preventing inherent bias. Only after the activity is verified as a severe policy violation is an authorized manager allowed to de-anonymize the user to take disciplinary action.
That is a crucial safeguard. Now let's look at the accidental side of data loss.
Right.
An employee isn't trying to steal anything, they're just moving too fast, and accidentally email a spreadsheet containing unencrypted customer credit card numbers to an external vendor.
This is where data loss prevention, or DLP, becomes the ultimate safety net. DLP policies are designed to prevent sensitive information from being inappropriately shared, transferred, or leaked, regardless of the user's intent.
The mechanics of DLP are fascinating because it's not just doing a simple Control-F word search across documents. According to the architecture documents, it uses deep content analysis.
If DLP relied on exact word matching, it would be useless. You can't program a system to look for every single specific 16-digit credit card number in the world. Instead, DLP utilizes regular expressions, or regex. Regex is a sequence of characters that specifies a search pattern. For example, it can look for any string formatted as 3 digits, a dash, 2 digits, a dash, and 4 digits, the pattern of a U.S. Social Security number.
But wait, if a supply chain company has part numbers formatted exactly like that, 3 digits, dash, 2 digits, dash, 4 digits, the DLP system is going to flag every single invoice as a Social Security number leak. The business would grind to a halt under a mountain of false positive alerts.
Which is why pattern matching is only the first step. Deep content analysis involves secondary validation. If the system finds a 16-digit number matching the pattern of a Visa card, it doesn't immediately block it. It runs an algorithmic checksum, like the Loon algorithm, to mathematically verify if it is a structurally valid credit card number. Furthermore, it looks for corroborative evidence in the proximity of the number. It scans the surrounding text for keywords like expiration date, CVV, or billing address.
So if the pattern, the checksum, and the keywords all align, the confidence level spikes to 95%.
Exactly. And once that high confidence threshold is met, the DLP policy enforces a restrictive action. If an employee tries to attach that document to an email going to an external Gmail address, the system intervenes. It might generate a policy tip, a pop-up, warning the user that they are violating company policy, forcing them to provide a business justification to proceed. Or it can simply block the email from sending entirely.
It applies data security at the granular file level, regardless of where the file travels. And speaking of compliance, organizations operate under strict legal frameworks, GDPR in Europe, HIPAA in healthcare. How does a company prove to their external auditors that the Microsoft Cloud infrastructure housing all this data is actually legally compliant?
For that, an administrator will utilize the Microsoft Service Trust Portal. This is the central repository where Microsoft publishes all of their independent third-party audit reports, their ISO certifications, and their detailed blueprints on how they implement security controls. If an auditor asks, how does Microsoft ensure physical security at the data center where our patient records are stored? You log into the Service Trust Portal, download the specific compliance report, and hand it to the auditor.
It provides the transparency necessary to trust a public cloud provider with highly regulated data.
Exactly. It also provides critical data residency information, confirming the exact geographic region where your data is physically stored at rest. which is a massive requirement for European data privacy laws.
So we have built the ultimate enterprise architecture. We have a hybrid cloud foundation. We have scalable PaaS and SaaS services. Our hybrid workers are collaborating flawlessly in Teams and SharePoint. We manage their devices with Intune. We have locked the doors with Enter ID, deployed the Defender XDR arsenal to hunt threats, and we are governing our data with Purview DLP. From an engineering perspective, it is a masterpiece. But from a business perspective, nothing runs for free. We need to talk about the final core objective of the MS-900 exam: pricing, licensing, and support.
The financial reality of cloud computing. The architecture is useless if the licensing costs bankrupt the company.
Exactly. When an organization decides to purchase Microsoft 365, they have a few different avenues to procure the licenses. The sources detail two primary purchasing channels: cloud solution providers, or CSP, and enterprise agreements, or EA. Walk me through the business strategy behind choosing one over the other.
It entirely comes down to the size of the organization and the need for flexibility versus the desire for steep discounts. Let's look at the CSP model first. A cloud solution provider is a certified Microsoft partner. They resell the licenses to end customers and often bundle in their own managed IT services. The defining characteristic of a CSP agreement is extreme flexibility.
It's the purest form of OpEx.
Yes, you can pay on a month-to-month basis. There are no massive upfront commitments. This is incredibly attractive for small to medium businesses or companies with highly variable workforces. Let's say you run a retail company that hires 200 seasonal temporary workers for the holiday shopping season in November and December. Through a CSP, you dynamically spin up 200 new Microsoft 365 licenses in October. In January, when the seasonal workers leave, you instantly spin down those 200 licenses, and your monthly bill immediately drops back to its baseline.
You only pay for exactly what you consume. But what if you are a massive multinational corporation with 50,000 employees? You aren't operating month to month. You want stability and volume discounts.
That is where the Enterprise Agreement, or EA, is utilized. An EA is designed for large organizations, typically those with 500 or more users, though the ideal target is much larger. It is a legally binding long-term commitment, almost always a 3-year contract. The organization commits to standardizing its IT infrastructure on Microsoft software for those 3 years.
You are trading agility for purchasing power.
Precisely. Because you are making a massive multi-year volume commitment, Microsoft offers significant negotiated discounts that you will never get through a CSP. The trade-off is that you cannot easily shrink your licensing count in the middle of the contract if you suddenly downsize your workforce.
Once you decide how you are buying the licenses, you have to navigate the incredibly complex maze of what you are actually buying. The specific subscription plans. The exam frequently presents scenarios asking you to recommend the most cost-effective plan for a specific user type. Let's simplify the main tiers.
We can divide them into two distinct families: the business plans and the enterprise plans. The Microsoft 365 business plans are strictly capped at 300 users. If your company has 301 employees, you cannot legally buy business licenses. You must move to enterprise.
Let's look at the nuances within the business family. We have Business Basic, Business Standard, and Business Premium.
The delineator is how the apps are delivered and the level of security included. Microsoft 365 Business Basic is the absolute entry-level tier. It gives you Exchange email, Teams, and SharePoint, but it only provides the web and mobile versions of the Office apps. You cannot install the full, rich desktop versions of Word or Excel on your PC.
So Business Basic is perfect for a frontline worker, maybe a factory floor manager who only needs to check email on their phone and look at a spreadsheet in a web browser.
Exactly. If the user needs the full installed desktop client of Word or Excel to run complex macros or work entirely offline, you must upgrade them to Microsoft 365 Business Standard.
And what does Business Premium add?
Business Premium adds the security and management layer. It takes the desktop apps from Standard and bundles in Microsoft Intune for device management and Microsoft Defender for Business to protect against advanced threats. It's the all-in-one package for a small business that wants enterprise-grade security.
Now let's jump up to the big leagues. The enterprise plans, designed for unlimited users. The primary decision point for architects here is choosing between the E3 plan and the E5 plan.
Microsoft 365 E3 is the core enterprise workhorse. It includes the full productivity suite, Windows Enterprise OS licensing, and fundamental security and compliance tools. It is incredibly robust. However, E5 is the premium, top-tier Cadillac offering.
The holy grail of licensing. If a scenario question asks for the most comprehensive security and compliance solution available, the answer is always E5. But what specifically drives the massive price increase from E3 to E5?
Automation, advanced analytics, and premium security features. E5 includes the entire Defender XDR suite endpoint, identity, Office 365, and cloud apps. It includes advanced voice capabilities, allowing teams to act as a complete PBX phone system replacement. It includes Power BI Pro for advanced data analytics.
And on the compliance side.
It includes automated data governance. While E3 lets you manually apply DLP labels, E5 uses machine learning to automatically discover and classify sensitive data across your entire environment without human intervention. It also includes advanced e-discovery tools for complex legal litigation and customer lockbox, which guarantees that Microsoft engineers cannot access your data during a support ticket without your explicit temporary approval.
Speaking of support tickets, let's talk about the nightmare scenario. You are a global logistics company. You are paying millions of dollars a year for an E5 enterprise agreement. Your entire global supply chain runs on Teams, Exchange, and SharePoint. Suddenly, a massive outage hits the Microsoft data center. Your entire communication infrastructure goes dark. Trucks are grounded, warehouses are paralyzed. What happens? Does the CIO just log onto a web portal, submit a standard support ticket, and wait 24 hours for a level 1 tech to reply via email?
If a global enterprise relies solely on standard support, they are making a massive strategic error. Standard support utilizes automated bots, community forums, and ticketing queues with basic response times. For mission-critical dependents, large organizations purchase unified or premier support contracts.
What does a premier support contract physically provide during a catastrophic outage?
It provides dedicated human resources and prioritized escalation. The organization is assigned a dedicated customer success account manager. When an outage hits, they aren't waiting in a queue. They have a direct line to specialized engineering teams. Premier support guarantees rapid response times, often within an hour, for critical business down situations. It also includes proactive advisory services where Microsoft engineers actively review the company's architecture to prevent outages from happening in the first place.
But even with premier support, the outage still happened. The logistics company lost millions of dollars in revenue while the system was down. Does Microsoft write them a check to cover those lost profits?
No. Cloud service agreements explicitly state that the provider is not liable for consequential damages or lost business revenue. However, cloud services are governed by strict SLA service level agreements.
Explain the financial mechanics of an SLA.
An SLA is a legally binding commitment that defines the specific performance metrics Microsoft guarantees to deliver. The most prominent metric is uptime availability, which, for core services like Exchange and Teams, is typically guaranteed at 99.9%.
That sounds impressive, but 3 nines of uptime still mathematically allows for roughly 43 minutes of downtime per month. If Microsoft fails to maintain that 99.9% uptime, what is the recourse?
If the downtime exceeds the allowed threshold defined in the SLA, the customer has the right to file a claim. If Microsoft investigates and validates the outage, they do not issue a cash refund. Instead, they issue service credits.
So a service credit is essentially a discount applied against the next month's invoice.
Exactly. It scales based on the severity of the outage. If uptime drops below 99.9%, you might get a 25% credit. If it drops below 99%, you might get a 50% credit. It is a financial penalty built into the contract that ensures Microsoft remains highly incentivized to invest billions of dollars into data center redundancy and resilience.
We have covered a truly massive amount of ground today. We tore down the physical office building and migrated its entire infrastructure into a global SaaS utility. We examined the back-end architecture that allows Teams, SharePoint, and OneDrive to function as a seamless digital workspace. We discussed how Intune bridges the gap to manage physical devices anywhere in the world.
And we explored the paradigm shift of the zero trust model. We looked at how Intra-ID utilizes conditional access to act as the ultimate pit boss, dynamically evaluating the risk of every single login attempt.
We unleashed the Defender XDR suite to automatically investigate and remediate ransomware, neutralize phishing links, and uncover shadow IT. We governed our data with Purview, utilizing rejects and deep content analysis to prevent accidental leaks. And finally, we navigated the complex financial realities of CapEx versus OpEx, enterprise agreements, and service-level agreements.
It is a comprehensive ecosystem designed to solve the fundamental challenge of modern IT, enabling productivity without sacrificing security.
But before we sign off, I want to leave you with a provocative thought that builds on everything we've just discussed. The technology landscape is not static, it is accelerating. The MS-900 study guides are already beginning to incorporate concepts surrounding Microsoft 365 Copilot, which integrates advanced generative artificial intelligence directly into Word, Teams, and SharePoint. Copilot can summarize your emails, draft reports based on your internal data, and generate action items from a Teams meeting.
It is a massive leap forward in productivity, but it introduces a fascinating new challenge for security architects.
Exactly. Throughout this deep dive, we have framed zero trust, conditional access, and data loss prevention entirely around human behavior. How do we stop an employee from clicking a bad link? How do we prevent a human from downloading sensitive files? But when an autonomous AI agent is indexing every single document in your SharePoint environment to answer natural language queries, the paradigm shifts again.
The security boundary becomes algorithmic. If an organization hasn't properly implemented purview classification labels, or if they haven't strictly enforced least privilege access, the Copilot AI might inadvertently surface highly confidential HR salary data to a junior employee simply because the AI had access to a poorly secured SharePoint site.
We are rapidly approaching a reality where the primary consumer of corporate data is not a human being, but an AI assistant. And that means we will soon be writing conditional access policies, assigning risk scores, and evaluating lateral movement not just for the accountant in Chicago, but for the artificial intelligence autonomously working alongside them. The AI will only be as secure as the zero trust foundation it is built upon.
It's an entirely new frontier of algorithmic governance.
From dissecting the raw compute power of bare metal servers to assigning identity privileges to artificial intelligence, the digital landscape is complex, but hopefully after this deep dive, the architecture running behind the scenes of your daily work is finally crystal clear. Thank you for joining us on this exploration. Keep questioning the technology you interact with every day, and if you are sitting for the MS-900 exam, trust the process, focus on the business use cases, and good luck. You've got this.